Welcome to Civil Engineering Structural Design Team. My name is Kidan Amara. Today I will show you how to design isolated footing within 10 minutes using ProtaStructure software based on European norm of standard and that of Ethiopian building code of standard. After completing watching this very useful video, all my audiences and students can design isolated footing both in square and rectangular shape within 10 minutes. Don't forget subscribe and share this channel to get more updated videos daily to project owners, structural designers, contractors, site supervisors, and that of civil engineering students. Let's start. Footings of a building broadly divided into main categories. These are shallow foundation and that of deep foundation types. Mostly shallow foundation types have a depth less than 3 meter and that of a deep foundation is or have a depth that is below 3 meter. Shallow foundation types mostly are those of isolated footing or individual footing, combined footing, mud foundation, and the last one is that a strap footing type or that of a strip footing type. And the second class or types of foundation of a building, mostly that is a deep foundation. More the types are pile and pit foundation types and that of basement foundation. I will show you designs of all these foundation types in next tutorial parts. Today, let's go to design isolated footing types on ProtaStructure software. Isolated footing type is nothing but it's a type of footing for each single column. This is why we call it individual footing. So to design isolated footing for our project, that is for our 8-story apartment building, first open your project on ProtaStructure and then go to analysis, building analysis. From building analysis, you have to check some parameters. So after you check all your parameters, so today tutorial is all about foundation. So from your foundation design, you have to edit the material here in project parameter. So go to edit material. From this, our today's lesson is more about foundation design. So go to foundation floor. From your foundation floor, you have to put some parameters here. So foundation, our concrete grade, it's better to use concrete grades of C30. Make it okay. So other parameters for concrete grades of C30 is provided like this. Your modulus of elasticity, shear modulus, poisonous ratio, all the data are fulfilled like this because you have to select your building code. So a steel grade, it's better to use steel grades of S500. So rebar diameter, you have to select rebar diameter because our project is 8-story building. So for footing design, it's better to use diameters of T12, diameters of 40, diameters of 60, and that of diameters of 20. Make it okay. After this, you have to insert your soil property. From geotechnical report or soil report, our soil is clay type, so you have to select clay soil, make it okay. After selecting this all data, it's better to insert your link property. So for link property, since our foundation type is isolated footing, link property of link is not necessary, so make it okay. After this, it's better to select your load combination. Before this, it's better to select our building code of a standard. So to select your building code of standard, that is error code. So all the data are selected like this before designs of the building. So you have to use all your data like this. So make it close. After this, it's better to analyze your building. So go to analysis. So building analysis. Building analysis is done. So uh, building analysis is done like this. Building analysis is done before. It's under okay. Building analysis. GitHub software by itself is done your building analysis like this. It takes some time. So it's better to wait after completing your building analysis and go to the designs of the designs of isolated footing. From the building analysis, the software itself gives all your axial load to the foundation at the foundation level. So using this axial load, you have to proceed to design isolated footing. It's better to wait until the software by itself finishes building design. Okay, it's good. The software is going to design the column reinforcement design and the axial load using the selected building code of standard, that is European norm of standard and that of Ethiopian building code of standard. It takes some time, so it's better to wait until the software finishes the design by itself using the data that we are going to fill or we are going to fill to the software itself. So it's better to wait. Okay. So building analysis is successfully completed. Make it close. Close. Go to plan. So from the plan, it's better to go to day 0, that is your foundation level. So to design isolated footing, it's better to select the column, right click, insert footing, insert pad footing. So okay, the ProtaStructure software template is coming like this to design your isolated footing of a column. So after this, it's better to go to material. So all the material and rebar grade that you have to insert on first page of software is coming like this. So the next thing is that column load. From building column load, that here is all the load combinations for the analysis of building. From this here, it's better to select combination 2, that is a factored combination for the designs of footing, all the footing. So You think this I will show this load combination at the final after completing the design. This load combination two is 1.35 dead load plus 1.5 live load. So it's better to use factored load combination two for designs of footing. From here, the load has an axial load of 3,127.2 kilonewton, and that of shear like this, and the movement in the x minus 11, and that of movement in the y is 5.57.9. Using this load or this axial load from your load combination, that is a load combination 2, you have to go to design our foundation. So to design your foundation, uh, from design template, the design template showed that our soil stress is failed, so it's better to our soil the foundation is failed using the stress, so it's better to add your dimensions of footing here, and the reinforcement in x direction, that is diameters 22, diameters of 16 is fail at a spacing of 200 is fail. So and that of in y direction is also fail. So it's better to increase your size, your reinforcement bar from diameters of 16. H16 means diameter of 16, and 22 is the number of reinforcement provided. So it's better to change it to diameter of 20 and decrease your spacing, or make it diameters of 16, and you have to decrease your spacing. So to solve this problem, because our design has failed, so to solve this problem, it's better to go to after it's better to go to design after selecting your load combination. It's better to go to design. So our footing type is failed also. So to improve this or to solve this problem, it's better to go to geometry. From the geometry, it's better to design your footing as a square or as a rectangular. So it's better to design your footing as a square. So here the problem is solved like this. Your soil stress or net bearing capacity divided by maximum soil stress is failed. So by you can solve this problem by increasing your section. So make it a square. After this, your soil stress or net bearing capacity divided by maximum soil stress. So your soil stress or your bearing capacity is greater than that of a maximum stress. So our design is okay. So after this, our footing dimension is like this: 4.1 meter by 4.1 meter is enough for this load combination. So the depths, the depths, the depths. If you have decreased these depths, our shear check at the face of column. So our shear is, our column, our footing is failed. So it's better to increase your footing. So our footing depth is 1.3 meter. So after this, you have to go to rebar. So you have to arrange your rebar shape. So a rebar in the x and a rebar in the y. Quantity is provided like this. So it's better to decrease the spacing as 150 first. So check. Still your spacing is not enough. So it's better to change it to 100. So still your okay, that is okay. So the required amount is enough. So it's change the color change into green. So you have to change this also 100, or you can change the diameters of bar to 20, and you have to increase your spacing. The next choice. So after this, our design is completed like this. You can generate your report, generate reports. So concrete material or concrete grade is C30. Rebar material is grade of 500. And our geometric property for your footing type is 401 by 4.1 meter by 4.1 meter, and that of 1.3 meter depth. And all the data are all the our building is designed using this load combination, that is factored load, and all the data is provided like this. So the software gives you all data and all stability check, and it checks all the requirements like this. So you have designed your isolated footing like this. Check all my videos. Check all my videos all about structural design using ETABS and ProtaStructure software, construction techniques. In the next tutorial parts, I will upload video on designs of all other foundation types. Subscribe and share my YouTube channel to get more updated videos daily. Thank you for watching, all my students and audiences.